Hello YouTube learners. Today in our video we are going to discuss about ray optics and optical instruments. Ray optics is a part of optics where we can divide optics in three parts actually. So ray optics or geometrical optics, wave optics and quantum optics. Quantum optics we don't discuss now. So we only discuss about ray optics and wave optics, and in this video lessons we are going to discuss ray optics. So let's start. In ray optics we will cover the topics like reflection and refraction. So you have to recall the properties of reflection and refraction of light. Then we will discuss about spherical mirrors, sign convention, then relation between focal length and radius of curvature, mirror formula we will derive. We will discuss about refractive index, total internal reflection, and again we will discuss about refraction at spherical surfaces and by lenses. And we also discuss about thin lenses, combination of thin lenses, prism, rainbow formation, scattering of light. And we will discuss about the optical instrument like simple and compound microscope and telescope. And more videos will be there where we will discuss about all the topics in summary for quick revision. So if you have not yet subscribed this channel, click the subscribe button and the bell icon so that you will get the notification of all new videos one by one. So let's start. In ray optics you can see we have to take some assumptions if we are studying light as ray optics. First assumption is that rectilinear propagation of light. So we have to consider light as it is traveling in straight line. So light travels in straight line in this manner. Again we have to consider laws of reflection and refraction valid for ray optics, and we have to consider that two light rays are totally independent of each other. So if one light ray is traveling near another light ray, then that light ray will not be affected by that nearby light ray. So that is the assumption that two light rays are totally independent of each other. So now let us start by asking a question: what is reflection of light and what are the laws associated with it? So the answer will be very simple, as we have already got about reflection and refraction. So answer is the phenomenon of bouncing, or you can write returning back, of light in the same medium when it incident on a surface. The surface has to be a reflecting surface. So that is the reflection of light. And what are the associated laws? We can write in this manner that the incident ray, the reflected ray and the normal to the reflecting surface. So it is important that the normal to the reflecting surface at the point of incidence. At the point of incidence, this is the point of incidence and this is the normal. This red color is the normal. All lie in the same plane. So all this lie in the same plane. The plane is this plane, not the mirror, this plane only. The perpendicular plane which passes through the normal, we can say. Second is the angle of incidence is equal to the angle of reflection. So all these things we have to recall to understand this lesson very nicely. So we have already got about the spherical mirrors. So to recall, you can see here, what do you mean by spherical mirrors? You can say mirrors whose reflecting surface is a part of a hollow sphere. So you can see this is a concave mirror and this is a convex mirror, and all the labelings are here. You can see this is focus, this one is the principal axis, this is pole, and the focal length is from pole to focus. The distance that is called focal length. This is the center of curvature, and all these things we have to recall to understand this chapter clearly. So now we will discuss about sign convention and relation between focal length and radius of curvature. So if you have not yet subscribed the channel, so I request you to subscribe the channel so that you will get all the videos one by one in details. So what is sign convention? In general we consider Cartesian sign convention. So you may get question like mention the rules of sign convention for a spherical mirror or lens. Then you have to write the answer in this manner. We know that the sign convention, if you consider, then all distances are measured from pole P or optical center. Optical center is for lens. So you can see this is the mirror and this is pole. So all distance are measured from pole. So you have to measure all the distance from here, from pole to any other direction. You have to measure the distance. First point is this. Second point is that principal axis of the mirror is taken as x-axis. So this is the principal axis and it is considered as x-axis. In Cartesian coordinate system we consider this principal axis now as x-axis. And third is distance measured in the direction of incident light is taken positive. So this is the direction of incident light, and if you measure the distance in this manner, that means in the direction of this incident light, then you will consider that distance as positive. And if you are measuring opposite to the direction of the incident light, then you have to take the distance as negative. And fourth point is the height measured upward with respect to x-axis and normal to principal axis of mirror or lens are taken as positive. So this is the principal axis, and it is normally we have to measure this normally. So you can see the height measured upward has to be positive, and on the other hand we can say fifth point, the height measured downward is taken as negative. It should be negative, it is not positive, it should be negative. So these are the sign convention, Cartesian sign convention. While doing all mirror problems or lens problems, we have to consider these sign conventions. We will understand it better if we do some problem. So we will do in our videos few problems also. Now let us see the relation between focal length and the radius of curvature. It is very easy to say that the focal length and the radius of curvature relation is nothing but f is equal to r by 2. That is, the focal length is the half of the radius of curvature. So you have to prove this. So you have to draw this diagram first. So let us draw this diagram, and you have to give some leveling of this diagram C, F, D, M, P. In this manner we have to give the labelings. Now let us do the derivation for this. So here you can see that we have considered here the angle MCP. So you can see here what is M, what is C, and what is P. So this is M, angle M, C, and P. So we have to consider this angle. This angle is nothing but theta. And angle MFP. So here you see M is this, F is this, P is this. So this angle is nothing but twice theta. So we have got these two angles, then we can write tan theta. What will be tan theta? Tan theta will be perpendicular by base. So perpendicular by base, you can see here in this triangle, you can say now that MCP, this triangle MCP, you can say tan theta will be the perpendicular. What is the perpendicular? You can see the perpendicular is MD. So MD by base is nothing but CD. So you can write here MD by CD. And in case of the triangle MFP, the perpendicular will be MD. It is same as the tan theta perpendicular. So MD, and the base will be FD. FD will be the base. We have assumed that CD and CP are equal because D and P are said to be very near to each other. So we can write in this manner. Now for small theta, if the theta is very small, we can write that tan theta is nothing but equal to theta, and similarly tan twice theta will be equal to twice theta. So this is the assumption for small theta angle. So therefore we can write MD by CD is nothing but, we have replaced tan theta as theta, so we have written MD by CD is equal to theta, and MD by FD is nothing but twice theta, because we have replaced tan twice theta with twice theta, so it will become twice theta now. MD by FD is equal to twice theta, and we can put this theta here because twice theta we have got theta is this, so MD by CD. Since MD by CD and here MD by FD, we can cancel MD and MD and we can rearrange it, and we can write here just FD is equal to CD by 2. So this is the derivation of the relation between the radius of curvature R and the focal length F. So we have got here FD is nothing, you can see from the diagram that FD is nothing, it is the focal length FD or FP, you can say FP. D and P are nearly equal, nearly at the same point, okay. And again this CD is nothing but C to, this is C to D, C to D is nothing but this is R, so you can write here R. So we have got the answer that we have derived this formula. So we have got, this is the answer, f is equal to r by 2. So this is the relation between focal length and radius of curvature. So in our next video we are going to discuss about mirror formula, refractive index, and furthermore videos will be there where we will discuss about total internal reflection, then refraction at spherical surfaces and refraction by lenses, thin lens formula, then combination of thin lenses, prism, rainbow formation, scattering of light, and optical instruments like compound microscope, simple microscope, telescope. And we will cover almost all the topics which fall in the chapter ray optics and optical instruments. So if you have not yet subscribed this channel, so I request you to subscribe the channel so that you will get all the videos one by one, and click the bell icon so that you will get the notification of all new videos. So thank you for watching. Inspire us to make more educational videos like this. So like, share and subscribe our channel.